All right, so what we're doing today is we're moving on. We're still solving, but now we're going to have a variable on each side of our equal sign. So we did one example of that last week, actually, where there was an X on both sides. So we're just going to do more of that today. So some equations are going to contain grouping symbols. So remember, that's either parentheses or brackets, and fraction bars. Okay. The steps for solving an equation can be summarized. So if you ever get lost, you can go back to see these 3 steps. Simplify the expression on each side. So remove any grouping symbols. Use the distributive property as needed. Step 2, we use the addition or subtraction properties to get the variables from one side of the equation to the other. So you want the variables to be on the same side. So we're going to move them to make that happen. And then we are going to treat it like we did last week, if we need to multiply or divide to get our X by itself. All right? So here we go. Words are nice, but seeing an actual example, I think, is even better. My first one, we have 5 minus 13c equals 4c plus 39. Okay? So a rule that I'm always going to do, I'm always going to move my variable to the left-hand side. Always. I'm always going to, because I want my answer to be X equals blank. C equals blank. I want that letter to be first. So I see that 4C is on the wrong side. That's what I'm going to move over first. So how am I going to move 4C to the other side? Is it a positive or a negative 4C right now? It's a positive. So how am I going to move it over? We're going to subtract it. And I'm going to subtract it from the other C because they're like terms. So I've moved my C over. I didn't touch the 5. The 5 is still there. Negative 13 minus 4 is now negative 17C. They're like terms, so they keep the C with them. And we're equal to 39. Now I'm going to move my constant, or my loose number, to be over with the 39. Because remember, we want the variable to be by itself. So how am I going to move 5 to be with 39? Subtract it. Because right now it's a positive 5. So we're going to subtract the 5 over here. That's gone. So now we have negative 17c, that sign stays with it, is equal 39 minus 5. Gives me 34. So when step 2 up here is talking about the addition or subtraction properties of equality, that's very fancy for add and subtract pieces to the other side. So that way we get just my variable equals just the number. Okay. So now I have negative 17c equals 34. Is my variable by itself? Not quite. There's still what attached to it. Negative 17, and how am I going to get rid of it? Divide. So it is negative. So like if I were to add it over, I would. But 17 and C are attached to each other right now by multiplying. So to undo that multiplication, we're going to divide. 34 divided by negative 17. You have calculators. Negative 2. We good? Okay. My next example has those parentheses that we were talking about. So step 1 told you to distribute, right? Take care of that grouping if you can. So when it says to distribute, what is that really asking you to do? If I was to distribute the 3, I'm going to multiply. So I'm going to distribute that first. None of this changes. So 3 times b is 3b, and 3 times 5 is 15. I noticed that I have like terms on the same side. I have negative 11 and positive 15 all on that same side together. So I can actually I can combine like terms. What is negative 11 plus 15? You got calculators. Come on, we got to use them. What is negative 11 plus 15? It should be positive 4 plus 3b. All right. Now what? What do you think we're going to do? What would you like to do? There's actually multiple answers to this. So how do you want to go from here? You want to subtract? What do you want to subtract? The 4, okay. Subtract my 4 from my 7. That gives me 3 equals 3b. If I say 3b equals 3, did I change the problem? No, you can do that. When it's equal sign, you can just flip-flop them across the equal sign if you would like to, if you like the way that looks better. What is attached to my b? A 3. How is it being attached? Right now it's multiplying, so how am I going to undo that? We're going to divide it. All right, 3 divided by 3 is 1. Like that. So there are lots of different ways to do these problems. So if you do a step differently than I do, but we get the same answer, it's very, very possible. Okay, there's lots of different ways to do this. You could have added 11 and then divided by 3 and then subtracted 5. That's another way this problem could have gone. I'm going to try to be consistent and like showing you the same way every time, but that does not mean that it's the only way. Yes? Any confusion? Not yet. Okay. Let's come down here to number 3. So right when you feel good, I'm going to throw a fraction in there. But what are fractions? We've talked about this, and we're going to keep talking about it. Fractions are division. That is 6x minus 9 divided by 5 equals 3x. I think we actually had this one last week. So how am I going to undo that divide by 5? Multiply by 5 to both sides. That gets rid of my denominator because we've moved it over. But 6x minus 9 is still here. But now we're equal to what? 15. So you get 15x. So 3 times 5 is 15, and then the x is still there. What would you like to do? Subtract the 6x, okay. So let's subtract 6x from my other x. That cancels this out. Now I have negative 9 is equal to, what is 15 minus 6? What was it? 9. Yep. 9x. What is attached to my x? A 9. How is it being attached? Right now it's being multiplied. So how am I going to undo it? Divide, yeah. There we go. What is negative 9 divided by 9? Negative 1. Good. So I have negative 1 equals x. I'm going to write my answer with my variable first. X equals negative 1. It's the same thing. I will always say x equals, b equals. I'll always have my answer be the letter first. How do we feel about that one? We're still okay? Mm-hmm. Do you remember doing that one last week? Maybe. Okay, number 4. What do we see happening in number 4? parentheses, okay? So there's no fractions, but I do see parentheses. So we're going to take care of it. How do we take care of it from the one right above this? What do we do? When I had 3 times b plus 5. What's that d? Distribute. We would distribute. So we're going to do it same down here. I'm going to do 3 times x, which is 3x, and 3 times 4, which is 12. Still have plus 3 on the end. Didn't mess with that. It's just still here. Equals, I'm going to distribute on the other side also. What's 5 times 2x? 10x. And 5 times negative 4? Negative 20. What do you see? What do you want to do? There is a lot. Yes, there is a lot. There's a lot happening at the very first, the 3x plus 12 plus 3, right? Could you put those together and simplify it, though? 12 plus 3? And make it not be as a lot? Yeah? Those are like terms. What is 12 plus 3? 15. So I can say 3x plus 15 equals 10x minus 20. So I've reduced it a little bit. I was able to combine like terms. All right, there's technically 4 correct steps that we could do next. Which one do you want to do? What do you want to move? You want to move the 3x, the 15, the 10x, or the negative 20? Which one you want to move? The 3x? Okay, how do you want to move the 3x? By subtraction. What am I going to subtract it from on the other side? 10. Good, the 10x. So those cancel, because 3x minus 3x is 0. 15 is still here. What is 10x minus 3x? 7x. And we still have minus 20. All right, what do you want to move now? 15. So I wouldn't move the 15. Because you see how we moved my variable over? Yes? So now I want the thing that's attached to my variable to get over to the other side. So I should move, let's add 20 to the other side. So you have your constants on one side and your variables on the other. I usually like my variable first, but I'm going with what y'all are feeling to do. So I don't want to go against your gut feeling because your gut feeling is right. 15 plus 20, 35 equals 7x. And our final step, divide by what? 7. Good. 35 divided by 7 is 5. So 5 equals x. But how am I going to write my answer? Yeah. Because Miss Douglas is OCD like that. We good? Mm-hmm. Yes? Okay. Y'all are just quiet. You just gotta let me know. Okay. Moving on to the back. All right, so we have some special cases, some special words that we need to talk about, okay? An equation has one solution if exactly one value of the variable makes the equation true. This is what we've been doing the entire time. We've gotten x equals blank, right? Just one number at the end, okay? Now, it is possible that there's no solution, and that's true if there's no value of the variable that can make the equation true. We might run into that and see what that's going to look like, okay? An identity is an equation that is true for all values of its variables, okay? Sometimes that's also called all real numbers or infinite solutions. It's all, you can put anything into this equation and it'll be true, okay? So there can be one answer, there could be none, or they could be all of them. Okay, typically we get just one solution, but it is possible to get the other two, and I want to make sure you see it. Ready? Yeah, let's do it. Okay. What do we see happening back here on number 1? A lot. And I see some grouping happening, right? I see the parentheses. So how do we deal with the grouping stuff? The arrows, yeah, distribution. Yep. So we're going to distribute 8 to G. What's 8 times G? 8G. There we go. And what is 8 times 6? 48. My other side, see how 5G is just 5G? Nothing special is happening to 5G on the other side. But 3 is part of my grouping, so 3 gets distributed. What is 3 times G? 3G. And what is 3 times 16? Come on. Calculator friends. What do we got? What is 3 times 16? 48. Thank you. Okay. So like last time, like Carla kind of said last time, a lot's happening. So when you kind of get overwhelmed like that, see, can I put anything together? Can I simplify any side of this equation? Yeah? What can we simplify together? Yeah, we can put those two together. So I didn't mess with this side. Okay, what is 5G plus 3G? 8G and plus 48. What do you notice?
It got smaller.
It did.
Oh, it's the same.
It's the exact same. 8G plus 48 equals 8G plus 48. So which one of my special cases do you think this is going to apply to? This is going to be the infinite one. So when they're equal to each other like this, no matter what I plug in for G, if I change G to a 2, both of those G's turn into a 2. Both sides are still the exact same. Does that make sense? A -2, a 100, a -74. No matter what I put in, because it's going to both sides, it's going to still stay the same. So this is called an identity. To follow the vocab from above, this is called an identity. And this is when we have infinite solutions. Because infinity goes forever. So this is showing all of them. It's like looking in a mirror. That's kind of where the whole identity comes from. If you're looking in the mirror, you're looking at yourself, right? It's a complete reflection. All right. Here we go. 5x plus 5 equals 3 times 5x minus 4 minus 10. Tell me what we need to do. You said it earlier, Travis. What are we going to do? The arrows, yes. And where am I doing that? With what number? The 3. Good. So 3 is going to get multiplied to 5x. And 3 is going to get multiplied to -4. Am I doing anything to the 5x plus 5 at the front? No, so it's still here. 5x plus 5. Okay, but now we're equal to what? What is 3 times 5x? 15x, good. And what is 3 times -4? -12. And then we still have minus 10x on the end. Okay, is there a lot going on? Yes, so is there anything we can simplify and combine together anywhere? Which ones? Good, or not the 5. The 15, because they're on the same side. You're good. So if I put those two together, I'm going to kind of do up here. 15x minus 10x, what is that going to give me? Careful. 15 minus 10. That's going to give me 5. So I have 5x plus 5, And now I have 5x minus 12.
I mean, that's the answer.
That's where we are right now. What would you like to do? Because we can keep going. Okay, subtract 5. 5x from both sides. Okay. Is it? What is, okay, you're good at subtraction. What's 5 minus 5? 0. No, 0. No, there's no more x's. I had 5 x's and they're gone. All the x's just disappeared. I'm left with 5 equals negative 12. They're gone. Does that make sense? 5 equals negative 12. Is that true? No, false. So guess what special case this is? This is no solution. Yep, this one is no solution. If I did that in the problem before, by the way, if I were to subtract AG to the other side, they would cancel out, just like we just saw, right? But you'd be left with 48 equals 48. And is that true? Yes. So that result shows us the infinite. Here, if I subtract and they cancel out, and I'm left with two numbers that are not the same, well, that's impossible. So that's going to show us a no solution. Okay. Yeah? We're good? With my special cases? We only have 2 more, right? Okay. Let's see what else happens. Can I let you try number 3? Yes, come on, you can do it. 3w plus 2 equals 7w. I want you to try. It could have one solution, it could have no solution, or it could have all the solutions. Okay, you try number 3. I want you to try this one. All right, so this one had one solution. It does have an answer. Okay, what do we want to do first? All right, subtract my 3w. Do that. Okay, so now I have 2 equals 4w. Okay, I saw a good amount of people say no solution here. You can't say that until you have 2 numbers equal to each other that aren't the same number. Like in number 2, when we got 5 equals negative 12 and my variable was gone, that's when you can determine if it's no solution. So if you get here, you can't determine that. There's still a w, okay? 4 is attached to my w by multiplying. So to undo it, you are going to divide. And we do get 2 divided by 4, which simplifies to 1/2. And if you use your calculators, if you do 2 divided by 4 in your calculator, you might have the answer as 0.5, which is also correct. So you could say w equals 1/2, or you could say w equals 0.5. What's up? I have an answer.
So I did 3 with the w. I did minus 3 and minus 3, but then you somehow got 4. Like,
7 minus 3 is 4.
no, I have it. Never mind.
And you still have the 2 on the other side, so that 4 has the w with it. Because you did 7w minus 3w.
I thought we get rid of it. So like eliminate the number down.
Nope. That only happens if you're subtracting the exact same thing. Like 5x minus 5x.
Oh, it's like
I had 5 of something, I took all 5 of that something away.
yeah, I didn't know that.
Yeah, here I have 7 watches. I took away 3 watches. I still have 4 watches. Does that make sense? So my W is still there. All right, lovelies. Last one. 3 times 2b minus 1 minus 7 equals 6b minus 10. What should we do first?
2b and 6b.
I can't do that.
Wait, why?
My steps tell me to take care of my parentheses, take care of my grouping. So we're going to distribute, yep. 3 times 2b equals what? 6b. And 3 times negative 1 is negative 3. I still have minus 7 over here. We're equal to 6b minus 10. Now what do we want to put together? Okay, parentheses is gone. Is there anything that I can like combine maybe? Not yet. Hold on. Yeah, -3 minus 7. Those were two constants, right? I can combine like terms. What is -3 minus 7? -10. Ooh, come on, pen. There we go. There we go. How do you know this is infinite? It's the exact same thing on both sides. Okay, if you took it, so you could stop right here. You have the proof this is infinite solutions. If you took it one step further and try to subtract your 6b from both sides and notice that they both end up being 0, we get -10 equals -10. Well, is that true? Yes, -10 is -10. So that's another way to prove that these are going to be infinite solutions. Okay, so you could stop at the blue or you can continue to the orange. They both prove that this is an identity, to use the vocab from the top, which means we have infinite solutions. There we go. Pen is doing weird things. There we go. Yeah? Cool. This is hole punched on purpose. So you're going to put it in your binder and you're going to keep it out because I'm going to come stamp for today's notes. Okay? And then you'll use this tomorrow to help with your assignment.